In this video, we will discuss about first. We will just let to know basic of queues. Then we will go into how what things are being given by C++ for working with queue. Okay, so let's first get to know what is queue. So this queue is nothing but it's known as first in first out. First in first out. First, what it is, what this means. From the meaning you can understand, the element which is coming first in the container or in the box will be eligible to come out first. Let's take an example. For an example, you can take an example of line at railway station. That is also known as queue, right? Okay, so why? See, in that you can see the person who is standing first will get a chance to take the ticket the first, right? Same way, that is known as queue. You can be someone might be referring like please be in queue, right? So that means you just be take your position. You will be serving after all the people who is in front of you, right? This means the person who came before you, they will get high priority than you. So that is nothing but queue. Okay, so technically it is known as first in first out, or in short it is telling as FIFO. Okay, first in first out. Okay, so let's first we will be describing this queue, how we are going to make this. So for now I will be referring for int, so I will try to enter some integer data. So this is queue. Let me insert some data. For inserting the data sorry, we having method of push in C++. It provides a method called push which will help you to push the element into the queue, but this is going to follow this property FIFO. You can say that is first in first out. Let's see how it will. First we have entered 10. Let me then enter 20. So 10 will be getting served first with respect to this 2030, and in this 2030 this 20 will get served first, right? Same way we will able to get the data. So how we are going to access the data in the queue? Queue is something you can get the data one by one. You cannot access any random data. You cannot access the data at element 2. If you want, then you have to reach to this element which having value of 20. So for that we will be accessing this one by one. Let's tell while this queue is not empty, means until and unless queue is not getting empty, I will try to run this. Okay, and what I will tell, just print the element which is at the first, that is front. Okay, so the next element, let's separate with comma or space. Now if I'm not doing anything, then it will get infinite, because just I'm getting this value and again I'm telling okay, get the element which is at the front. So still this is at the front, means first element or first person has not got served till now, means they are ready to serve but has not been completed. So if that person is getting completed, then I will tell okay, you just go out from this queue. Okay, so this is going to work. Let me print this. See the output: 10, 20 and 30. So first person is 10, then next person is 20, then next person is 30. Okay, so be having some more methods, more functions which I will tell you. If you want element at the end, at the back, so for now at this instance this queue is empty. Let's see, queue is empty or not. It will tell you. See, it is telling yes, queue is empty. Okay, queue is empty or not, that is telling true. So let's get this size, and all these three people got served. So here this time no person are there inside the queue, that's why it is 0. It will be 0. Let's see, size is 0. Earlier it was empty, means yeah, that is 0. Size is 0. Empty 1 means it is true, it is empty, that's why size becoming 0. Okay, so what I will do here, only I will try to the back element be having two, first method is front, second method is back. So let me comment this. Just right now check it, you will be getting some size 3. Yeah, you are getting 3, correct? So yeah, see 3 we are getting. Okay, so now let me show you if we are trying to get the back element. See what will happen, this is going to pop anyhow the first element, this 10 will be popped out, but it will try to print first 30, then this 10 will getting removed. Again this will try to print this 30 and 20 will get removed. Again this will 30 print and will remove this 30. Let's see, 30 30 30. Whatever you have to do, just do it. If you are going to fire a method called queue.pop, this is only the element, this is only the method to pop the element which is going to follow the property of queue. It will tell okay, whatever you want to print, you just print it, I don't care, but I will delete only the first element, only the first element, because this is the person who need to be served, and I am expecting after firing pop you have served this element. But you are printing back, that's fine, just get the back element, but I will delete the first element because this is the person who came first. So I will tell this person as a served till now. So 10 is getting deleted and this back is getting printed 30. Again this 10 is not there, now 20 and 30 is there. So this pop will remove this 20, before that this again back is getting printed 30. So second 30, now this 20 is got popped out. Again only 30 is there, which is front, which is back, whatever you referring, that is the same element. So again it will print this 30 and will get popped out. There is one more method called in place, that is also going to use as a push. It will help you to insert an element at the end of the queue. Let's try to do that. Just get this size right now, what you are getting. Let's see, it should be 0, right? Okay, size is 0. Let me insert with the help of queue.inplace method. Okay, and let's try to get this data once again. You see only 40 you are getting, so this is inserting at the end. Okay, let me comment this and just check it. Okay, so 40 40 40 means at the end you are getting 40, but it would be better if we are trying to access the front element. So this will help you to understand. Let's see, 10 20 30 40, at the end we are getting this 40. So this is the in place method. So let's talk about the time complexity of these methods or of these functions. So time complexity is one of the really very important part, as we are in the era where we have to think about our memory as well. So every method are big O of 1 only, because we are not computing anything, just for method push, for pushing element at the end, or getting the element from the front, or getting the element from the back, or removing the element from the end, which front only queue. So that is also big of 1 time complexity. So every function whatever we have discussed, that is behaving with big O of 1. Okay, a queue is provided of size n and someone is telling just remove all the element and tell me the final time complexity, what it would be. So what it would be, big O of 1 for each element, and for n element we are calculating, so big O of n. So in that way, means this is the basic thing that we have to know. So that's done with the queue, and we'll discuss in some another video regarding priority queue and stacks. That's it from this video. Thanks for watching. We'll meet in the next video.